I'm going to try to get a better quality recording of the audio this time. I've got a little voice recorder, and we'll see if I can use that to sync it with the video later. All right, so if you're not yet enrolled, keep on attending, completing assignments. Email me to get access to CCLE and PIC Lab. If you need it, actually, I don't think I can give you access to PIC Lab at that point. Just bring your laptops until you can get enrolled, which can happen in the third week of class. Keep checking the wait list. At the end of the second week, you'll be automatically enrolled if you're on the wait list, and others can be added by late petition in the third week if there's space. So that's how enrollment works. There's not exceptions to that. I've never been able to make an exception because I don't have PT numbers or ways of enrolling you other than late petitions, and they only accept the late petitions in the third week. So at that point, it'll be first come, first served, but it looks like there's space, right? I think everybody has a seat so far, and you know, you guys can't see me during lecture, or you can't see me during lecture, then you know, you can always move your seat somewhere else in the classroom and get back to your chair later. Okay. So today we're going to do a little introduction to the Python language. We've got a little bit done last time. As I ended up number my lectures like this. Week 1, today is Wednesday, so that's how you can find out where we are in the course. If you're reviewing these slides, they're already posted online. Some announcements. Preparation 1F has been posted on CCLE, so you can start getting ready for next time. And today, I've already posted assignment 1W, so that's something that you can work on during class today. Or you can start preparing for preparation, for 1F if you'd like. If you know that you're not going to want to do this assignment, you'll get to see it. It's a little bit more mathy than 1F will be. So because you only have to do half the assignment, you get to choose between 1W and 1F. Now, you can't see 1F until Friday, but that's how it's going to work. Office hours today, I had some from 10:25 to 11:25 a.m. I also will have them today in the afternoon, 2:25 to 3:25. So take a look at the syllabus for other office hours. What questions do you have about the preparation you did for today before we get started? Yeah.
I was able to get the sorted function to work.
Okay.
The original data was modified. I was able to get it to work where the original data was copied.
I see.
And nothing I was able to figure out was the default arguments.
Okay.
The one without 1 to 10 and get 30.
Gotcha. All right, so one question was about the sorted function. That sounds like it's a little bit code specific. You understand what you're supposed to do. You probably could write a sorting function in some other language. Yeah. So, and you can get it to work when you copy the things, but not when it was supposed to change it in place. We can take a look, during class today, we can look at your specific codes. That's one of the advantages of having a flipped classroom. You prepare ahead of time, you've given your shot at something, and I can help you specifically in class with sorted function. Now, default arguments was something that you read this time, and was there a specific question about that, like how those work? Default arguments are great because they make it so that you don't have to overload functions anymore just to have a default value for a parameter. So I'll just write a simple example right now. We're creating a function, say f, and it's got 2 parameters. One is x, and one is y. Then I can call this function in multiple ways. If I call this function like f, then it uses the default values for x is 2 and y is 3 because they didn't provide anything, and it just multiplies them together. It'll print out 6. If I call this function like this, f of 2, let's say f of 4, then it's going to use 4 for x because that's the first argument. It's going to use the 3 for y. It's going to do 4 times 3. It's going to print out 12. If I call the function like this, f of 5, 10, then x is going to get 5, y is going to get 10, and it's going to print out 50. I can do some other things in Python as well. So notice we didn't have to overload the function in order to get these different behaviors. Normally in C++, you'd have to have 3 versions of the function. One is for when you have f with no arguments, one is when you have f with one argument, one is when you have f with two arguments. But you can do even more things with Python. You can also specify that you want f of y gets 10, right? This is going to leave the default value of x alone and allow you to specify what y is. This is going to be 2 times 10 is 20. Lots of different things that you could do here. Does that answer your questions about default arguments?
Yeah, I heard comment that.
Yes, equals. Yeah, it's kind of funny. This is not this is kind of assignment. It's the y that's inside the function is going to get the value of 10, and it takes precedence over whatever's written here. Yeah.
The number that's like f of y equals 10, that the y has to match whatever the argument variable name is.
It needs to match the parameter name, right? If you put z here, it's not going to know what you're talking about.
What would happen?
It's an error.
Oh, it's just an error.
Yeah.
Okay.
Yeah?
So just following off of that, is it okay if I like declare like f of y equals 5, comma x equals 4?
So
like it's
yeah,
like
you
order?
can do them out of order. You could say y is 5 and x is 10 or something like that. And then you would say, x is 10, y is 5, multiplied together. One thing you can't do is start with y and then start specifying just 10. It doesn't know where to put this 10 because this is in the second place, but you've already talked about y. It's confusing. They could come up with some convention, but you can't do that. You can't start off with named parameters and then switch to ordered parameters.
Can you do x equals 5,
No, you couldn't do that either. X equals 5, comma 10, because it's still starting with the named parameter and then continue on to ordered parameters. You can do it the other direction though. You can say, let's say this thing had 3, z is 10, and we're going to multiply all 3 of them together. You could say, start off with 2, and then skip y by saying z is 20. You can do that. That makes sense. It's going to start with the order. It's going to apply them for as many as you gave it, and then it's going to skip over to whatever you told it, the name parameters. Yeah?
This is a separate question, but so for like when you have like immutable objects like lists, and
Yeah.
like the text said that if you specify that in as a parameter in the function, if you change that, then it'll just keep using that same. So like, why does the none keyword there like actually like work in this
Why
equation?
don't you ask me? We're going to talk a little. So I don't think that's going to hurt you on the quiz. Let's wait until I'm going to talk a little bit about mutability, immutability, references, that sort of thing later on. Does that sound like a good time to ask that?
Yeah.
Okay. Got a little bit of that. Yeah. Lambda expressions. Okay. Let me go ahead and skip to that part then. I'll explain those before the quiz. So let's see. All you need to know, at least for the quiz, and we can talk a little bit more about application later, because you'll have the opportunity to try out lambda expressions in today's lecture. Well, let's say you have a regular function that fits on a single line, and you're going to call it like print f of 2. This is how this function is going to be called. It's going to do something with 2, and it's a very simple thing that it does. So this is the function I want here, okay? This is how you write it. You write that keyword def. That means I'm going to define a function. It's going to be called f. That's the name of the function. The argument is going to be 2. That's what I'm passing in. So x is going to take on the value of 2, and then what's the function? You have to specify a colon. That means that's the end of the signature. I'm just done saying what my function is going to be called, what it's going to accept, etc. Now I'm going to get to what my function actually does. That's what the colon says. The returns happens at the end of your function. This is just a simple one-line function, so you could have a body of the function here, right? But now we're just going to get to exactly what we want the function to return. We just want it to take x squared and add 1, and that's what's going to send out. So when we call this, it's going to print out 5. 2 squared plus 1, 5. Everybody understands how a regular function works. Let's show the lambda expression version of this same function. So the equivalent lambda expression is this here. We start out saying this is the name of the function. This is what we want to refer to the function as, f. Okay? Then you write equal sign, because f is getting, actually, even functions defined like this, you can assign later on. Like if I just define my function like this, later on I could say g gets f, and then I could say g of 2. It would do exactly the same thing. Now I can refer to the function f by g. So there's a difference now between the name of a function, what we're calling it, and the function itself. And lambda expressions kind of make that explicit. We're creating a function here, and we're calling it f. Okay, so we're assigning it, and that's what the assignment operator is for. Then we've got the keyword lambda. Instead of def, instead of defining a function, we're creating a lambda expression. It's a special kind of expression that can only, it has just one line. You specify whatever parameters without any parentheses, which I find kind of odd, but it's actually consistent with other programming languages, how they do the same sort of thing. They say what the parameter is. So what, if you have parameter x comma y up here, you'd have x comma y down here before the colon, just like it's before the colon up there as well. And then you've got whatever you want to return. So if you've got a one-line function, or if you think you want to create a lambda expression, you can go ahead and write it as a regular function, and then copy and paste, the relevant things in the right places. You say, here's what you want to call it, the equal sign. Instead of def, you use lambda. You bring the x, or whatever arguments or parameters you're going to have, down there next. The colon happens right after those parameters. And whatever you were going to return from the function, that's what you put there. Lambda functions, however, they can only be one line long. You can't have like an if statement and multiple things, and it returns different things depending on what it is. Is that not the lambda expressions?
Yeah, I think actually I'm realizing, not because of the language, but it might be more specific. So I was asking.
That particular, so their example of what a lambda expression is used for is kind of odd.
Okay, yeah.
Okay, but this is the basics of the lambda expression. Yeah.
Why would I implement a lambda expression
As opposed to this, there's a few reasons. One, it's more compact, but B, it lets you do interesting things like in the application that they show you, and we'll see those later in the course, but it might not be completely clear now. That's okay. Yeah. For now, just know how to read them, not necessarily how to use them. That's okay. Yeah, another question?
Yeah, in the preparation about arbitrary argument lists, I talked about tuples.
Yeah, don't worry about tuples yet. I'm going to say later, you don't know what tuples are, you don't know what dictionaries are yet, that's okay. We'll see those next time. We'll see that the next chapter in this tutorial is data structures. And we'll talk about them then. Yeah. No. You can't quite do that, like g or f plus 2, is that what you're saying? Not exactly, but you could create a lambda function. So this is one thing, okay, this is actually maybe a good question. It might get at your question about why you might want to use a lambda function. Let's say that you want a function called g that does whatever f does, except you always want to add 2 to it. Well, in that case, g, you don't necessarily need to create a whole other function that does it. You can say g gets lambda, I guess x, lambda x, is going to call f of x and then add 2 to the result. So in one line, you just kind of convenient like that. But besides that, let's say you wanted to create a function that adds 2, or could add 3, or could add 4 to it. Okay? And so in that case, you could have, let's see, what? Comma y. Yeah, you could do that. It's just not exactly what I wanted to do. Yeah, and you could do f of x plus y. You could still do that with a regular function. The example that they give you in the code shows it better. And that will do what we were just talking about. A little bit more compactly than you could do it otherwise. Other questions? Okay, cool. Then now it's time for, so both of these work the same way. References and mutability we'll talk about in a little bit, but now I want you to work on the quiz. So please complete the quiz, 1W on CCLE. I'll give you about 10 minutes before I start talking again. Actually just 5 minutes, right? Because that's all you have for the quiz. Password's Cheetah. As I worked on the MIT Cheetah robot when I was over there. I ask that you not look at references while you're working on the quiz. This is supposed to come from your brain. I think the quiz is going to kick you out in a second here. So finish up. Everybody still working? To the bitter end, right?
Yep.
Gotcha.
Wait, are these just quizzes we can get extra points?
Yeah, you can get extra points. I probably, you probably deserve some points for those questions you guys were asking just a second ago, but I'm sorry that I forget about these sometimes. So remind me maybe.
That's correct.
Just ask another few questions. You've got plenty of time to record. Come to office hours, I think should take as well. Oh, okay, yeah, retroactively. If you came to office hours, I'll give you one retroactively, I'll take that. Come to me after class, that's cool. All right, anybody still working on the quiz still? Yes? Okay. All right, what questions do you have about the quiz? Yeah.
I had a question about the previous quiz, is that okay?
Okay, the previous quiz, yeah, the one that was supposed to be up for Monday, sure.
Yeah, the one with the power, there was like two answers that like could have been, I thought could have been, the one was power 2, 5.
POW 2.5.
Yeah, and
The
then there
thing is,
was,
if you want to use POW, I don't think that's a built-in function. I think it's part of the math module.
oh, okay.
Can you just type in POW 2.5?
Yeah, because on the documentation, it was one of the options, so I picked it, but it was wrong.
Then email me, and everybody who did that will get credit if that's the case. But I believe that you have to import the math module in order to make that possibility. So send me an email, I'll take a look at that. What other questions are there about the quiz we just took? All right. Next in the future, I'll probably should set like an initial time and a final time, like right here when we're done with the initial questions, so that I know exactly when we can stop, and I'll figure that out next time. By the end of today, I want you all doing all these same things that we wrote in the preparation. So I'm going to talk about a few of them. We were just talking about lambda expressions, and I also want to talk a little bit about something from last time. First of all, you don't need to know what tuples or dictionaries are yet. So Brent mentioned those in reading. If you didn't quite understand those, don't worry about it. You can come back and get those parts after we do tuples and dictionaries, which is in the reading for next time. You also don't need to know how to take command line input yet. That's something we talked about. You don't need to worry about that. I'll explain lambda functions, which I just did, and the meaning of slicing in Python is totally different from the meaning of slicing in C++. Slicing in C++ is when you had an object and you like a subclass, and you stored it in a superclass variable, and then that stripped away any of the subclass parts of that subclass object. Slicing in Python is talking about, if you've got a list and you want to get a range of elements from that, for some part of the middle out of it, or alternating, or reverse it. That's slicing in Python. Totally different, unrelated concept. We talked about lambda expressions just a second ago, and now I also wanted to bring up something about references and mutability, so go ahead and ask that question you had before again. Similar code can behave differently depending on whether the variable is a value or a pointer, or a reference, or mutable or immutable. So let's look at some C++ code here. Int x gets 1, y is x, y gets 10, C out x. Raise your hand, what's the answer for this one? What's it going to see out?
1.
It's going to see out 1. Why does it do that? Let's envision the variable x as a box. It's going to get 1 inside it. Y is another variable. We're going to represent it as a box. Y gets the value from x. So we take this over and we put it in y. It gets 1. Now we say y gets 10. That means to change whatever's in y to 10. See out x, that means look at x, print that out. It's going to print out 1. Good. Excellent. So, I'll start doing this. Good. Excellent. Now, what if I had had an ampersand in just the right place? I'm going to get maybe a different result this time. What's the result from this code? Raise your hand. Yes? Yes. Okay, good. There you go. Why does that work? referencing, dereferencing, all that. All right, so we've got this box, x, it takes on the value 1. We've got this other box I'm going to call y, but really it's just a reference, kind of like a pointer, to x, right? So then if we say y gets 10, well that really means x gets 10. And so when we print out x, we get 10. Excellent. So that's a bit of C++. Now let's look at what Python does. Now first of all, I want you to know, Python, all variables are references to objects. It doesn't have to be explicit. You don't have to have the ampersand. You don't have to have the asterisk for a pointer. Even an int is an object, as it turns out. We'll talk about why you don't get what you might expect from that in just a second. All right, here's this code. X gets 1, 2, y is x, etc., etc. Who can tell me the result of this code? Yeah. 10 as well, so let's see, 10, 2, he says. Close. 0, 0 is. Yeah. So let's take a look at this. We'll do it carefully, okay? I'm saying that x is some reference to a list that's somewhere in memory. If that list is 1, 2. Okay? So x is just a reference over to that. And then y gets x, that really means y refers to the same thing that x does. Now when we say change y, element 1 to 10, that changes this to a 10. When we print x, x is pointing to the same thing. So we're going to get 1, 10. So good. You got the right idea. All right. Now finally, I'm going to tell you something. So lists are mutable, but some types, like ints, floats, strings, are immutable. You cannot change them. You can only create new ones. And so the assignment operator doesn't change the existing variable or object. It creates a new one instead. So that's why. So let me just go ahead and draw the diagram for this one. Keep in mind, this is Python, this is C++. So it's going to, the effect is going to be very similar to what you would expect in C++, but it's accomplishing it somewhat differently. In Python, we have a variable called x, but that really points to some integer object in memory that has the value 1. We also have a variable called y that initially points to the same object that x does. But then we say y gets 10. Unfortunately, because, well, not unfortunately, it doesn't matter. We cannot change this. This is immutable. It's an integer object. It's a special kind of object. It's not like a list. We cannot change it. So instead, it creates a new object that takes the value 10 and says, y, you're now referring to that instead. So now when you print out x, it prints out 1, unlike what you might have expected, even though, so you end up getting the same sort of results with primitives and strings that you would expect from, say, C++. It works the same way, but it's accomplishing it in a different way. It doesn't actually store that value in x. It stores it in some other object, but those objects are immutable, so it has to create new ones when it try it. It looks like you're trying to change it, yeah.
Why does int stored in a list is mutable?
Well, I guess you can think of the list object. Okay, so let's get picky about it. He says, let's see, let's say I have, let's go back here. Let's say I have x is 1, 2, right? Here's my variable called x, and it stores a reference to this thing. Oh, sorry, you can't see what I'm writing, can you? It refers over to that. But really, 1 and 2 are technically our other objects, right? 1 and 2, that this list points to. Okay? So when we change y element 1 gets 10, what we're really doing is we're saying we're going to create a new integer called like 10, and we're going to say we don't need you anymore, 2. Garbage collection. We're just going to point over to 10. So, yeah, good question. I'll go ahead and give this to you then. Awesome. Cool. Other questions about this? Does that make it clear what I was trying to specify last time? Yeah.
I was trying to find a function and I created like a certain variable to store like a number in the list. Like it was an error. I couldn't do it. Is there a reason for that?
So can you give me an example code?
So it was a define function and then like it took in like a list as a parameter.
Okay, so define def f, let's say we
Like
call
X,
this
yeah.
list x.
So if I write like y gets x bracket 0 or something,
Uh-huh.
like that didn't work for me.
There's no reason why that shouldn't work,
Okay.
as long as x has already been defined out here. And you pass it into the function when you call it.
Okay, I'll check it
So
out.
if I say, like here, I define my function, I say x gets 1, 2, and I call f of x, then there shouldn't be any problem. It should store the zero value of this x in the variable y locally.
Okay.
So I'll take a look at your code. Yeah, it should work like you expect. Yeah.
So in that case, we're not releasing it at one, that's clear, right? So how do we, delete that?
How do you delete it?
Yeah.
Well, you can always delete variables. I think in the next reading, you're gonna learn about the del keyword. You can
Oh.
remove a variable from memory, but you don't have to worry about it. I mean, you can always, are you saying, how do you get rid of this object?
Yeah,
I mean, you can always reassign x. X now gets 2, x gets 5. It's the same as in C++. You can change what the value of a variable is. You don't have to worry though about cleaning these objects up after yourself. You don't have to. Yeah, it automatically garbage collects. So basically, whenever it creates objects, if it realizes that there is no variable that is referring to them anymore, then it can just get rid of it. It can never get it back. So that's automatic garbage collection for you. You don't have to worry about that. You had new and delete in C++, you don't need those anymore. No more memory leaks like that. Okay, so your options for the rest of the time. Try assignment 1W. It's somewhat mathy. If you have questions about it, call me over, or you can come to office hours. If you don't like it, you can work on exercises from last time, or you can practice the 1W stuff, and you can enjoy the rest of your class time however you see fit. And most of the rest of the class is going to be just me coming over you individually. Okay? Okay, I'll come over to you.
Actually, it's just a general question. What are the preparation notebooks that you post online?
Oh, I guess I meant, okay, I did need to mention that. I posted preparation notebooks online, and that is my notebook that I use when going through my own preparation 1W assignment. Those are the things that I typed out and got the results from. So it's just convenience for you to see afterwards what I typed out. And it's basically what you might have typed out if you follow the preparation. You can open them in Jupyter by downloading them as IPYNB files. It stands for IPython Notebook NB file. Now it's called Jupyter instead of IPython Notebook. And just make sure it's in the right directory and you can browse to it from within Jupyter. You can't just double click it. Jupyter does not open it magically. Jupyter is a funny program. It doesn't work like that. Yeah. Yes, just the order. So you can use either the order or you can name them explicitly. Just like in C++, right? The order, it does not that. You can do that, yeah. But if you don't put X for this, Y gets this. If you don't say, if you don't say F of X gets 1, Z gets 10, etc., you don't put the letters, it's going to go by order. Which ones? Today? Anything like that? thought I chose to write 4 class. Okay. Maybe I put it in my Java class. 18 somewhere. There's no differentiate function, you're gonna take the derivative yourself, manually. Right, yeah, I mean, don't worry about it for now. It's basically, if the user were to type in a function and its derivative, give both of those things, give an initial guess, etc., then your function, this Duke's method function, could calculate that. Oh, it's a little bit different, but yeah, all we need to do is print out the number. You don't have to print out all the intermediate stuff. And this is optional. It is, like you can imagine, you could write a lambda function. Right here, I've got that. And it is both the function and the derivative. And those are both returned by the lambda function in a list. And so in your function, you unpack that and, yeah.
For the function of the assignment, so is it like we should create 4 different functions and program each one with the...
That would be okay. You could do that. Or if you use this notation down here, you can basically pass in the function that you're trying to solve as an argument.
Oh, okay.
Yeah, it's another way. And so then I could write one function, and then I could write 4 test cases. Did you want to show me the code that you were having trouble with?
I was having trouble with it like on Monday, but like now
It's fine.
it's working. I don't know why.
1 second, he actually got me first. Yes. So you have Alright, so let's look in here. Where is it? You have to find it in here. So you need to probably put it in one of the folders that you have there, or that this can access, and then the whole directory is difficult. I suggest for simplicity, put this in your listing in the directory. Yeah. I've done it before on my own computer, but like, this will help you probably underline it. This is a longer question. You probably have to start it from the command line and put that directory. I don't like Jupyter for that reason, but for now, he got me first. Hey. That's fine. Yeah, that's okay. That's one way to do it. And I think if you finished it already, try this. Yep, those are the only ones you need to test. That's okay. Your function doesn't always work. So that's fine. I don't require yours to always work.